now I'm just getting a drawing, and I'm going to look at the drawing of the plate, and I'm going to see all the critical values of what needs to be, what's the most critical features on the plate. Ideally dowel pins or spot faces, pilots. And from that, I review that, and then that I can take that and know what exactly I need to tell the ferro arm I want to measure. So I can see that there's 2 dowel pins in the center, which is our index table dowels. I know that. And there are. And there's some dowels out of the stations here, which are critical that I have to measure. So it's a fairly simple plate as far as setting it up, knowing what to measure. And from that we can zoom in here so you can see this is the actual CAD model. We import it. And from that we just select the features that we want to measure, and we set our tolerances, and then we just get to measuring, and it tells us how in spec we are. We have to activate all the encoders first. It's got 3 different encoders. There's one at the base, there's one at this pivot point up here, and then there's one right at the end. Just move them around, activate them. Once they realize the movements, they're activated, and it's ready to then go and calibrate it. For this one, we're using only a 3mm ball probe, which is at the very end here. We just set it inside the cone and plot points. We get a sigma value saying that the arm passed the calibration and it's within tolerances of the arm. And now from that we're all set up and we're ready to begin the measuring. So the first thing I do is I'm going to take 3 features and 3 features only, and I'm going to measure. One's going to be the flatness, and then the 2 center dowels of the plate.
Okay.
And from those features I'm going to create an axis, and I'm going to align the plate using the plane of the flatness, the axis, and one of the dowel pins for a centering point. Measure the plane. So we measure the plane at each feature as well, and then we bring the probe inside. We are essentially aligning the CAD model to the real life product.
Okay.
Now we have 3 values already measured, and we're going to go ahead and we're going to highlight the rest of the dowel pins that need measured. What's nice after you align it is the ferro arm knows its position and knows the feature of what you set to measure next, so it'll broadcast it on the screen where you're at. As you get close, it'll zoom in for you. The first feature we're going to do is the constraining plane around our dowel pin, and then we're actually going to go inside the hole, probe the inner diameter. So all our values are measured except for circle 8, which is the dial is still not far enough inside to reach. But at this point, we just go into the report, and we will set all of our tolerances, and that'll tell us if we achieve what we're trying to manufacture or not.
Finished inspection report.
So this is a typical finished inspection report.
This one, there's only 4 dowel pins that we inspected on it.
This one, there's only 4 dowel pins that we inspected on it.
The drawing number, the device
put
that
the organization, the drawing number,
the
device that we measured it on, any inspection notes, and
prior to measuring
this plate in particular, we use gauge pins prior to measuring it to double check the diameters.
And we put the limitations of the arm on it as well.
And we put the limitations of the arm on it as well. And here's your actual CMM
features
table
see,
printout
everything we measured
for all
off
the
here on the right
features.
passes
As you can see, everything we
tolerances
measured
to
off here on the right
print.
passes
You
tolerances
can
of
see
the
nominal
print.
values.
You
as
can
opposed to
see
the actual
the
measured
nominal values
with tolerances.
as opposed to the actual measured values with tolerances.